Hello everyone, let's take a look at our next problem. A thin hoop of diameter d is thrown onto an infinitely large chessboard with squares of side length L. What is the chance of the hoop enclosing two colors? Okay, so when it says enclosing two colors, I mean, the way I'm going to interpret this is simply that the hoop has to touch at least two different squares on the chessboard. I suppose another interpretation would be that it has to there must be two full squares within the hoop. So that's not the interpretation I'm gonna make. I'm gonna use the first interpretation where it must touch at least two different squares. Now, if the radius of the hoop is sufficiently large, then this will always happen, right? If the diameter is greater than the side length, then it doesn't matter where you throw it. It'll always touch at least two squares. So we're going to assume that the diameter d is less than L. And I want to think about what might be a good way to parameterize this. So if I parameterize everything in terms of the center of the circle, so let me, okay, yeah, what I'm going to do is the center of the circle, we'll call it xy. And I need to think for a second if it's enough to, if it's, without loss of generality, to just assume that x and y are uniformly distributed between 0 and L. I think so, right? Like, yeah, so x is going to be uniform between 0 and L. Y is also going to be uniform between 0 and L. They'll be independent. And so, we don't even need to draw a full, or even more than one square. We can really just draw one square, and we're asking what is the probability that the hoop touches or goes over top of one of the edges. Okay. Okay, so I throw my hoop into this square. The hoop has, okay, and so what I'm looking for at this point then, this is L by L. What I need now is I need to find the region inside this square where if the center of the circle lands there, the hoop will be fully contained within the square. And that's basically going to be, it's going to be a region which looks something like this. I'm going to draw this on the grid sort of, but of course the exact shape of this is going to depend on the exact sizes of D and L. Okay, so we'll have a quarter circle here, followed by a straight line segment. Quarter circle here, straight line segment. Quarter circle here, straight line segment. Quarter circle, and a straight line segment. This is what the region would look like if this is the radius of the circle. Okay, so if the center of the circle lands anywhere inside this region, and I then draw the circle of radius r, it will not touch, or it will just exactly touch the edge of the square, right? At the extreme case, if we are exactly a distance r away from the edge, then our circle will look like this, and it's just touching the edge at this point. If we're down, if we land on a corner here, oh wait, hold on. No, this is what the outline of the whole, this is what, like, where this shape includes where the edge of the circle could land. So really, the center of the circle would have to land somewhere inside this square. Yeah, okay. The center of the circle would have to land somewhere in there. If the center of the circle is here, then the distance to the edge is less than or equal to r, so we will go outside of the square. If we are on the edge of this smaller square or inside it, the circle will just touch or be fully contained within the square. Okay, so let's think for a second here. Okay, so the diameter being less than r, this really means that the radius is less than L over 2. And we can see that, if the radius is exactly L over 2, then the only place that we can throw the circle, the center would have to land directly in the center. And then we would have a circle inscribed in the square. So let's find, the relationship between, I want to find the size of this square. Well, it's clearly going to be the side length of that square. Let's call it S. Well, the relationship I need here is that S plus 2R is equal to L. So S is equal to L minus D. Okay, let's make sure this makes sense. If the diameter of the circle is L, then like we said, this square actually reduces to a single point right at the center. If the diameter of the hoop is 0, then the hoop can land anywhere in the square, it doesn't matter. So the probability we land inside that square, assuming things are uniformly distributed, is just going to be the area of the square divided by the area of the small square divided by the area of the large square. So this is going to be the probability, I'll say probability I, probability of landing inside, which is L minus D squared over L squared. This is the probability that the hoop contains only one color. So the probability, let me expand this because we're going to have a 1 inside this and we're going to want to cancel that. So we get 1 minus 2d over L plus d squared over L. So the probability we actually want, I'll call this P2 for probability of containing 2 colors in the chessboard, is 1 minus the probability of there being only 1 color. And so this is going to give us 2d over L minus d squared over L. Yeah, that was a nice little geometric problem. I almost slipped up in computing the area of this region, which is basically the entire area that could contain any part of the circle if it only contains, if the circle only enclosed 1 color. But yeah, I guess I was lucky to see my mistake and correct it quickly. yeah, it's good in a problem like this to always sort of parameterize things, draw a picture, figure out what it is you're being asked to do exactly. And we could do a little bit of sanity check on this too to make sure that as D approaches L, we get 0. Does that happen? If D is equal to L, we have 2 minus L squared over L. Oh my, okay, I've got a mistake somewhere. What am I doing wrong? What am I doing wrong? Well, sorry, hold on. I'm confusing the two events here in my head again. When D is 0, the probability should be 0, and it is, because you have no chance of enclosing two colors. When D is equal to L, we should get 1. I'm missing a squared here. There we go. Okay, so when D is equal to L, we get 2 minus 1 is equal to 1, which is what we want. Yeah, all right, okay. So just missing this little exponent. You know, I wouldn't have guessed what this expression was at the outset of this problem, but there you go. Thanks for watching.